to the surface and freezes, turns into new seabed or new crust. And what's so interesting about this molten magma is that it contains iron particles. And these iron particles, they align with the magnetic field. And when we look at the seafloor close to the ridge, we see these alternating belts where the iron particles point in opposite directions. And it shows very clearly how Earth's magnetic field has changed with time, how the north magnetic pole and south magnetic pole have swapped places. And when we measure how quickly these plates move away from each other, we can also begin to estimate how often Earth's magnetic field has changed in the past. And that was the first time it really dawned on me that by making observations of our world, thinking about it, understanding the processes, we could understand our own planet. We can understand planetary processes even if they'd happened hundreds and thousands of years ago. And I found that really, really inspiring. We don't really know how Earth's magnetic field is generated. We have some ideas, but basically we still don't really understand it. And we certainly don't understand how the north magnetic pole and the south magnetic pole can swap places. So this is still an area that we're very interested in, also at the European Space Agency. And currently we have a mission called SWARM, which consists of 3 satellites circling the Earth and measuring Earth's magnetic field, how it changes with time, and how it's affected by things like the solar wind. And when we look at the data that we're currently receiving from SWARM, we see, well, lots of interesting things. It looks like the strength of Earth's magnetic field is currently falling, which could imply that within the next maybe 10,000 years, Earth's magnetic field or the poles will again swap places. What this means for Earth and all life on Earth, we don't really know. So this is an area of active research that we're also working with. As the years went by and I came to high school, my fascination with space grew. I also began reading popular science books. And one of the things that back then mystified me, and even to this day mystifies me and mystifies most scientists, is that if we look out at the universe and we count everything that we can see, then everything that we call matter, normal matter, the matter that I'm made of, the matter that you're made of, the matter that this building is made of, accounts for only about 5% of the universe. Then there's about 25% that we call dark matter and about 70% that we call dark energy. Why do we call it dark matter and dark energy? Well, because we don't really know what it is and we have to call it something, so we call it dark. But again, I find this optimistic because if only 5% of the universe is known to us, if 95% is still sort of unknown, it must mean that there are still lots of things we don't understand and lots of discoveries waiting for us in the future. So if anyone, any of the children here tonight is interested in a scientific career, I'm certain that during your lifetimes you'll make many, many exciting discoveries. And of course, this is also something that we're working with at the European Space Agency. In the last few years, we've had 2 different missions to study this, Herschel and Planck. These are space telescopes that try to understand how the universe was formed, how it's evolved with time, and what it consists of today. So again, an area of active research trying to understand the universe around us. In high school, I also became fascinated with the planet Mars, and this is one of my favorite pictures or maps of Mars. It's a map of the height of the surface taken or made from radar altimetry measurements by satellites in orbit about Mars. And it really shows why Mars is such a fascinating planet. The color here, so the blue colors signify low-lying areas, while the yellow, oranges, reds, and white signify high elevation areas. So for example, you can see these 3 white dots and this big white dot here. These are volcanoes. This is Olympus Mons, the largest volcano in the whole solar system. But one of the first things you notice when you look at this map is that in many ways, Mars is composed of 2 different hemispheres. There's the northern hemisphere, which is blue in color, meaning it's mostly low elevation areas. And then there's the southern hemisphere, which is high elevation areas. And if you look closely, you notice something else. On the northern hemisphere, there are very few craters. And it reminds us a little bit of Earth. If we go outside and look around us, we don't see very many craters here on Earth. And the reason we don't see a lot of craters is because we have erosion. We have wind, water, weather that helps to erase craters after they've been formed. On the other hand, on the southern hemisphere of Mars, we see lots and lots of craters. And it reminds us a lot of the moon. And the reason there's a lot of craters on the moon is because there's no weather phenomena. So once a crater has been formed, it's there for almost eternity. Now, statistically speaking, there ought to be just as many craters up here in the north as there are down here in the south, which means that there must have been some process that has erased these craters. We don't know exactly what it is. It could potentially be lava, but it could also be liquid or flowing water. And that's immensely interesting because we think that liquid water is one of the prerequisites for life. So maybe if there was water on the surface of Mars millions or billions of years ago, there might also have been life. And I'm not talking about intelligent green aliens, but bacteria and other microorganisms. And this is, of course, also something that we're very much interested in learning more about. And in 2020, ESA will send this ExoMars rover towards Mars with the purpose of landing on Mars and then searching for signs of water and signs of life. It has a small drill that can drill maybe 0.5 meter into the soil on Mars and analyze that soil for signs of life and water. So again, a very interesting area of research that we're working with at the European Space Agency. Even today, I'm still fascinated and inspired by some of the missions that we work with at the European Space Agency. It's become very popular nowadays to take selfies, and I think this is one of the coolest selfies that's ever been taken. This is the Rosetta spacecraft that took a picture of itself. You can see one of its solar panels here, and then you can see the comet 67P that Rosetta is orbiting around. And if you look closely, and maybe we need to turn down the lights a little bit, but if you look closely, you can even see a stream or a jet of gas that the comet here is shooting out into space. Rosetta was launched all the way back in 2004, and it took 10 years for the spacecraft to reach the comet and to enter orbit about it. It's since stopped working, but for the couple years that it was in orbit, it took really stunning pictures like this and sent them down to us. And you can find many pictures like this on the internet. So when I was finished with high school and I had to decide on an education, even though I had this dream of becoming an astronaut, I knew that the chances of that were very, very small. But my interest in space exploration was still so strong that I knew that that's what I wanted to work with, even if I couldn't be an astronaut. And so I chose to become an aerospace engineer, because then I thought, well, then I can help build spacecraft like Rosetta if I can't go into space myself. And so I took a degree in aerospace engineering. I came here to Instituto Superior Tecnico as an exchange student, and I became a spacecraft engineer. And then in 2009, I was lucky enough that the European Space Agency was again looking for new astronauts, and I applied together with almost 10,000 other Europeans. And after a full year of all different sorts of tests, I was lucky to be among the 6 new European astronauts that started training. And then I spent the following 6 years at the European Astronaut Center in Cologne, Germany, training and learning everything I needed to know before embarking on my first mission to the International Space Station in 2015. And the International Space Station is just an incredible place to live and work. This is what it looks like today. This picture was taken just over 2 months ago on the 4th of October by a colleague of mine just before he returned to Earth after 6 months in space. They flew around the space station and were able to take some pictures. And it's really incredible. This is probably the biggest engineering marvel that we humans have ever undertaken. The space station is enormous. It's about the size of a football field, so it's about 100 meters across here, and it's about 80 meters long. It's so big that you can't send it into space or launch it in one piece, so we had to assemble it piece by piece. And the very first module, the first piece, was launched 20 years ago in November 1998. And then we spent the next 12, 13 years assembling it piece by piece until it became this size. This also means that this year is the 20th birthday of the International Space Station. It took us close to 2 years to get enough modules up there before the first astronauts could move on board. So on the 2nd of November 2000, the first 3 astronauts moved on board the space station. And ever since